Hello and welcome to Ought in Math. In this edition of Ought in Math, we're going to talk about, real briefly, the Hinge theorems and go through one practice problem. All right, so let's get started. Hinge theorem. So the Hinge theorem says that if I have two sides of a triangle, and I leave the triangle, the third side of the triangle open just for demonstration. If two sides of one triangle are congruent to two sides of another triangle, so AC is congruent to BX and AD is congruent to BY, and the included angle in the first triangle, so we'll call this triangle number 1, is greater than the included angle in the second triangle, so we'll call this triangle 2, then the remaining side of the first triangle, which would be CD, is going to be greater than the remaining side of the second triangle. All right, so let's take this as the example. Angle A, in this case, I have AC congruent to BX, AD congruent to BY. So the Hinge theorem says that if angle A is greater than angle B, then CD, this length here, CD is going to be longer or larger than XY. Right, so that's the Hinge theorem. Again, if two sides of one triangle are congruent to two sides of another, and the included angle in the first is greater than the included angle, remember the included angle is that angle that's sandwiched between the two sides of the second, and the remaining side of the first triangle, the side that's open, is going to be greater than the remaining side of the second triangle. All right, so converse of the Hinge theorem says now that if I have two sides of one triangle are congruent to two sides of another triangle, and the third side, so not the angle now, the third side BC is greater than the third side YZ, so we'll call this again triangle 1 and triangle 2, then the included angle of the first is going to be greater than the included angle of the second. All right, so I have AB congruent to XY, AC congruent to XZ. Then if BC is greater than YZ, I know that angle A is going to be greater than angle X. So that's the converse of the Hinge theorem. So in the Hinge theorem, for my students, in a proof, or if you're explaining the Hinge theorem, you can abbreviate the Hinge theorem as SAS with an equal sign and a slash through it. And for the converse of the Hinge theorem, we can write SSS and then a sign that equals with a slash through it. Okay, so those are the two Hinge theorems, very straightforward. So let's just take on one practice problem. What I'd like for you to do is pause, think about the problem itself, try to answer it on your own. Then we'll come back and we'll go through the answer. All right, so given diagram is shown. AB is congruent to BC, so I have an isosceles triangle. I need to determine the relationship of the following segments and explain the reasoning. So AD versus DC, AB versus BC, BD versus DC, and AB versus AC. So you can pause for a second, see if you can figure this out on your own. Come back and we'll explain the relationship of the different sides. Okay, so we're back, and let me show you the answers. Right, so I have AD is less than DC. So actually, let's just fill out some of what we're missing here. I have an isosceles triangle, so I know the base angles are going to be congruent. Remember, because if the sides are congruent, then the angles opposite them are congruent. I know that I'm given that ABD is 35 degrees, DBC is 45 degrees. So the sum of those two angles is equal to 80 degrees. So ABC, angle ABC is 80 degrees. We know that the sum of the measures of the angles of a triangle are equal to 180 degrees. So we're left with 100 degrees divided by 2 leaves us with 50 degrees for both angle A and angle C. All right, we also know, because this is 45 degrees, DBC is 45 degrees, that BDC is 85 degrees. So in figuring out what AD and DC, the relationship of AD and DC, we can go back to the Hinge theorem, which says that if I have two sides of a triangle which are congruent, so I have AB and DB are congruent to BC and DB. DB is congruent to itself, and the angle included in one of them is larger than the other, then I know that the side opposite the larger angle is going to be larger than the side opposite the smaller angle. So I know that DC in this case is going to be greater than AD. Right, what about AB versus BC? Well, that's pretty easy. We've already defined this as an isosceles triangle. So AB is equal to BC. And we can say that BD is greater than DC. So BD is greater than DC. And why is that? Well, we'll have to go back to our lesson on inequalities in a triangle to realize that if in a triangle I have an angle that's larger than another angle, the side opposite the larger angle is going to be longer than the side opposite the smaller angle. So in this case I have BD, which is opposite 50 degrees, and I have DC, which is opposite 45 degrees. So since 50 is greater than 45, BD is going to be greater than DC. And also AC is going to be greater than AB because the side opposite AC is going to be, the side opposite angle ABC, which is 80 degrees, is AC. And 80 degrees is larger than 50 degrees, or the angle that supports the side AB, the side that's opposite the 50 degree angle. So since angle C is less than angle ABC, side AB is going to be less than AC. All right, very quick lesson for the Hinge theorem, just 2 to learn. Good review problem for you. We've got a couple practice problems involving the Hinge theorem, so come back and join us in the practice session of the Hinge theorems in the next edition of Autumn Math.